What do you guys want to bet? I can finish this whole liter of Dr. Pepper before the end of the podcast. Welcome to the Slant 3D podcast, the show about 3D printing and our place inside the industry. Today we're going to be talking about Hugging Face buying a 3D printed robot, glass-filled PLA, and a bioprinter. Finishing off with a discussion about how we figured out how to dry filament faster than anybody else without using any energy, and discussing teleport and the API updates. Finishing it off with a discussion of negative feedback, and I have no doubt some of you are looking for some response to drama, which we will get to. So, without further ado, let's go ahead and pay the bills. This episode is brought to you by Teleport. Teleport is our new print-on-demand software that allows anyone to just upload a model so that whenever you get an order, Slant 3D will print the item and ship it directly to your customer for you. No more having to worry about packing up boxes and making sure the machines are maintained and everything is operational and you have the right stuff. You just offload all of that so that you can focus on designing good products and creating a great business around the products that you create. So go ahead and check it out over at slantpod.com. That's slantpod.com. Like, no joke, guys, I probably am going to drink this all. I'm just going to leave this open. Not a sponsor, but it's just good stuff. Okay, first piece of news. TissueLabs launches Advanced Tissue Pro Bioprinter for labs ready to scale up. Swiss biotech company TissueLabs has launched its most advanced bioprinter yet, the Tissue Pro. Built for tissue engineering and regenerative medicine, the new machine features precise multi-material printing, more automation, and greater flexibility compared to the company's early models. It builds on the success of the Tissue Smart, the company's entry-level bioprinter, used in over 300 labs across more than 30 countries. While it opened the door for researchers entering the bioprinting field, Tissue Pro is meant for labs ready to scale up and tackle complex tissue models, organ-on-a-chip systems, vascularized constructs, and other advanced applications. So, a bioprinter. A bioprinter is a 3D printer that puts down basically beads of biological material. It might be tissue growth, it might be cells, it might just be freaking bacteria, dishes of whatever, in order to just let it grow and have it placed in a specific sort of way. The goal is for these printers to eventually build basically the scaffolding for organs, and organs themselves too, but for now, with the technology, let's just say scaffolding, the baseline kind of biological construct, so like fat and cartilage and that kind of thing, to where then like heart cells could grow into that, and then you could 3D print a full-shaped heart. And it has a lot of promise. And with stem cell research and the rest of it, it could work. It technically can work. There's been proof of this kind of stuff working. And 3D printing, this is one of the advantages of printing because it's really tough to injection mold a heart. Biological systems are very complex, and things like arteries and everything else are tough. Where 3D printing can create those types of pieces, they could technically be grown from the patient's own base cells and go from there. This is all highly speculative at this point, but it's theoretically feasible. So it's cool because 3D printed bioprinters haven't really been like fully utilized. Like no one's really made a really high level one. Or I would even say like a highly moddable one. Like the TissueLab machines are very Prusa-esque in how they look. One of these days we'll get podcast updated to where I can clip to views of these different stories. This is per 3dprint.com. But bioprinters are just still very embryonic to where they could go a lot further with more baseline materials to work with and that kind of stuff to where people could play around with it. So it would be interesting to see. But we'll go ahead and move on to next story there. Hugging Face buys humanoid robotics startup. This is highly unprofessional of me. Hugging Face buys the robotics startup Robotics, a robotics startup based in France, for an undisclosed amount. Wired reports that Hugging Face plans to sell Pollen's humanoid robot, Ricci 2, and let developers download and suggest improvements to its code. Pollen Robotics, which aims to bring affordable human robots to the home, was founded in 2016. The company managed to raise 2.5 million euros from investors, including BPI France, prior to its exit, according to Crunchbase. Okay, the Pollen Robotics Ricci robot, which, you know what, I'm just going to go ahead and do this dirty. That Ricci robot Pollen had the Ricci one was a 3D printed robot, upper body humanoid robot with a couple cameras and kind of emotive antennas and that kind of stuff. The reason I know this company very well is because I have a copy of the 3D printing files stored on my computer from when I was operating a robotics company or working with robotics over at Slant Concepts. Pollen Robotics was a project that I really appreciated, and the work that they were doing was really good. With the advent of the ChatGPT era, Pollen Robotics basically upgraded Ricci with Ricci 2 and gave it more metal components rather than 3D printed components, because Ricci 1 was an emotive robot. It was able to move around, but it wasn't really very functional because it was all plastic parts and kind of off-the-shelf sort of servos, so it wasn't very durable. But the Ricci 2 is machined, a lot heavier duty. It has one big old arm and then a mobile base. It's meant to be this edge into humanoid robotics. Hugging Face, of course, is an open source AI company, effectively, an AI marketplace. What would you guys quantify Hugging Face as? It's like a weird GitHub for AI or an app store for AI right now. It's kind of a weird situation. But they would be interested in Pollen because every AI company has some robotics testing or tendril. And this is basically Hugging Face's reach. And Hugging Face is also based in Europe, so they need a European robotics company. Based on where Pollen was, I'm going to guess that the purchase price was somewhere between $10 and $20 million. Maybe even less. It's more of kind of an acqui-hire sort of situation. They get a hold of the files and the IP and the talent so that they can continue to develop on it and build it from there and build the team from there, because there's this baseline hardware to work from. This is actually old news. I will fully admit that this is old news. This was discussed and brought up in the middle of April, and this is being filmed at the end of June. But we were light on 3D printing news, so I wanted to hit this. I also want to experiment with slightly broader news of 3D printing, but maybe 3D printing in use in places that's generally not directly understood that it's in use. So 3D printed houses, components inside of the Tesla car, that kind of stuff. That where it's like, 3D printing was there, but like it's not mainstream that 3D printing was there. But this acquisition is just interesting because the Ricci Robotics robots are heavily 3D printed robots, and they're cool, and it's cool, and humanoid robots are cool, and AI is pretty nifty. So yes, I went ahead and did that. Next to a story for all 3DP, PolyMaker releases high temperature PLA and high temperature PLA glass filled. This is generally a story we don't do very often. We generally do not do company announcements of products. The reason being is that they're not really very newsy or very interesting, and they're generally paid for articles inside of a lot of publications. But the reason I bring this up is because last week we talked about glass-filled filament. Glass-filled, in this context, the PolyMaker high temperature PLA is pretty high temp. They do a demo of it in a video where ABS, PETG, they all tip over, but the high temp PLA, after being annealed, is able to resist higher temps. This is the dirty little secret of high temperature PLA. High temperature PLA is only higher temp after being annealed, which is the process by which you print the part and then you place it into an oven, bring it back up to temp, and the crystals are able to grow inside of the part so that it stabilizes more. And then you take it back out of the oven, it cools down, and now it is even higher temp than when it was originally created. This is a weird thing of amorphous plastics, like PLA. But it is interesting. They added the glass filling to it in order to also improve its rigidity. Because now that it can resist the temperature in the plastic itself, you can get higher rigidity by using glass filled to it. My own personal opinion of using glass filled in filaments is to give it kind of a rougher surface texture so that you eliminate layer lines. I don't know if they have a high enough density to achieve that with this PLA, and I actually cannot tell from the demo of the video. If somebody has tried the high temp PLA from PolyMaker glass filled, let me know. We will probably also try it at some point also, and this is something interesting enough to do on Tangled testing at some point in the future, or if we release it on Teleport, we would release qualification about that. Okay. And affordable too, with high temperature PLA running $26.99 per kilo and glass filled running $32.99. That temperature differential is not due to the material itself, I wouldn't say, unless there's a really high compounding cost. But it also, glass filled, here's the challenge with glass filled and carbon fiber chopped filled materials. It really wears out your extruder quickly. And by extruder, I mean the filament extruder, not the 3D printer extruder, the thing actually making the filament. Big old board machine with a big old giant screw inside of it that's all chromoly and hardened steel. Glass filled materials and carbon fiber materials really chew that up quickly. And you generally see it in the die of the nozzle, the nozzle of the extruder, which is hardened steel. It's been machined to have the extrusion diameter. But then you also see it in the screw in the bore itself. So on a large industrial extruder, you have to replace the barrel and the screw intermittently based on wear. And a lot of things can wear on it. Those extruders are just, they're not as finicky as 3D printer extruders, but they're not. Okay. Next piece of news. That's it for the news. That is it for the news. Okay. Moving on to the Tangled update. So, Tangled update. We're doing okay. Another bunch of big old print farm orders came through because, of course, they did, right when we were getting caught up. But Tangled is staying caught up. Like, we're keeping pace with it, and this isn't like wildly out of whack. We were just about to get way ahead, and we were having stuff on the shelves, and then people bought all the stuff off the shelves again. But we're staying up with it. We will be purchasing another extruder. So we have 2 extruders right now committed to Tangled. We'll be getting a third. The third one is interesting because it's bigger than the other ones. Our other 2 extruders are 45 millimeter bore screw diameter extruders, which means that they're pretty slow. They're pretty small. They're generally spec'd for going somewhere between 10 and 20 kilograms per hour or so, which sounds really slow. And I know it's really slow. We have discussed about Tangled extrusion being really slow and filament extrusion in general being really slow. The 50 millimeter diameter screw actually gets us up to about 50 kilograms an hour, just because of the wonderful math of circles. So that will speed us up quite a bit. It won't arrive for a couple of months once we get a hold of it. We're going through and kind of designing it. Anyone who is interested in extrusion will be interested in this. It will not have an accumulator. We have that removed, and we are working with them to change the chilling on the bore of it, and we may remove one of the water tanks and use our own, the final cooling water tank, because they're often not long enough. And then we are having them rework the winder to be a single spool large winder, because spooling directly from the extruder is stupid. You have no control of the process. Somebody has to maintain it. It's very high labor. You should not. I don't think any filament manufacturer should have spool changing at the end of the extrusion line, because you have a high opportunity for waste, error, and problems. That extruder is going to get ordered and probably going to be built over the next couple of months or so, and that will allow us to continue to scale up Tangled, and also presumably allow us to increase number of materials. So pushing on PETG, other colors, so on and so forth, which is exciting. Tangled will also probably be moving into its own building in the near-ish future because of that third extruder, because we do not have any more room for it here in our Boise facility. So, but we have more space right over there. Drying innovation. This is cool. Here's a trick I'm about to share that no one knows, no one appreciates, and the extrusion industry as a whole, I'm pretty sure, could learn from it really usefully, but we'll never know about it. If you are running filament production, go ahead and steal this. This is our gift to you. I'm open sourcing it right now. So at the end of an extrusion line, you have an extruder over here. It's shooting filament out. It goes down through to water tanks. Those two water tanks go from high temperature to ambient temperature in order to cool the filament as it is extruded. It then goes out of the water tank and it hits what's called an air curtain. An air curtain is compressed air, and the filament is going through the cylinder circle right here, this hole. The compressed air hits it and blows off the water as it's going through this air curtain right here. The air curtains are stupid and terrible because they run on compressed air. They shouldn't run off compressed air. If you need that type of air, it should be continuous fan flow. But it does have to be high pressure air, and fans don't like being under high pressure. That causes a lot of vibration inside of the fan, which causes the fan lifetime to decrease. And when you have an extruder that operates 5 days continuously without pausing, the fans burn out because they're under pressure. An air compressor is bad though, because you are doing too much work on the air to get to that pressure. So ultimately, drying the filament uses a lot of energy from compressing the air, and also is just very unreliable. If the filament goes through the air curtain slightly off center, then it does not dry reliably, and you can end up with just a little bit of mist still left on it. A lot of extrusion lines get around this by having it run through the accumulator, which ends up being like about 120 yards of continuous travel running over wheels. So it has time to kind of air dry. The vibration and rolling over wheels and everything else knocks off the last bit of that mist before it goes to spooling. We don't want the accumulator because the accumulator is a high risk mechanism that is tough to string, tough to train on, and tough to fix when it goes wrong. So it's not good for Tangled, where we're optimizing every part of the process. However, we were working with this problem the other day, and I was talking with the guys in Tangled, and we were like, okay, how can we dry this filament without having to do all this blowing on it, having to go as hard as we can across it? And we said, well, what if we just ran it through, 10 feet of rags after the end of the extrusion and have that water wick away as the filament runs over it? So kind of the mechanical pressure of the filament running over it would continually press water into the rags as it goes by. And we're like, oh, that's kind of cool. Let's go ahead and try that. So we took a board, cut out a 6-inch wide board, and we put microfiber cloths over it because we have them around for like cleaning beds inside the facility. Laid down a layer of microfiber cloths and then put it at the end of the extrusion line. So the filament came out, turned off the air curtain, and had it just run over the over this microfiber over the top of it about 6-10 feet, and then over to the spooler. And we would test the moisture at the end of the spooler, just as we do. And we would also measure how fast those rags would accumulate water. Fascinating discovery. The rags that, when we had that 8 feet of microfiber cloths, after 48 hours of operation, they did not all become saturated with liquid. And here's what's fascinating. This is an unoptimized thing, 6-inch wide board with microfiber on it. Microfiber is an exceptionally good wicking material because it's microfiber, small fibers that are able to move water through really readily. And if you have high pressure water in the format of more water being added at the center from the filament, it forces more water out through the edges and the wicking allows it to be moved. The thing we added to this is our cloths were wide enough that they dangled over the edge, so the water is forced from the center out over the edges and then down. With those edges hanging down, the water inside the flaps is being pulled by gravity, which creates a low pressure wicking area. So you have high pressure from the filament inserting water right here in the center, and then you have low pressure from the gravity pulling water away on the edges, so you're pulling the water away just with gravity. So these things were draining themselves completely passively as fast as water was coming out on the filament. That is the discovery. What we've since done is we've done some more testing. We had 8 feet, never got it all wet. What we discovered is that you can actually get about 95% of the water off in about 6 inches using this microfiber and other stuff. And then you have another like 1 to 2 feet of just like final drying, which is sort of like a tunnel design to make sure that you get a full 360 on the filament. So instead of having an air compressor system or a blower fan, which are noisy, energy intensive, and everything else, we have 1.5 feet of totally passive mechanical drying that is self-operational, does not break down, power doesn't go out, and works better. And that is how we are going to dry filament from now on in all of our lines. Because even if the lines double in speed to where like water, I don't know if the water output will double or not, we can just make it longer. So it's stupidly scalable even in an industrial context. And I don't know if people know this or not, but we tried it out. This might be something that exists already, but I didn't go looking very hard for it, and it certainly doesn't come with the extrusion lines when you're purchasing them as an option. So there you go, extrusion world. You can absolutely use passive drying if you're using microfiber. Regular cloth will saturate, but you can use microfiber cloth with gravity in order to pull water away from filament as it's pulled out. And this is one of those fun little innovations that we get to run into here at Slant 3D. There's a lot of these inside of the factory. Like there's stuff inside of our machines, stuff inside the software, stuff inside the workflows. But like the Tangled ones, we don't mind sharing because we want the industry to get better at all this stuff. So this is one that we're throwing out there, and I'll bet you that it gets buried and most of the people won't ever know about this. So I also don't feel bad about sharing this idea. Sam Altman was talking about this once. He was talking at Y Combinator, which is a startup incubator. And he said, don't worry about people stealing your idea. The reason is everybody has their own stuff going on. They don't care about your idea. If you put the best idea on Tim Cook's desk that would totally be great for Apple and has proven numbers and is a surefire hit, it would probably get ignored because they're on their road and they're doing their stuff. This is probably going to get ignored. This would be very helpful to lots of folks to not have to have air compressors drying out filament. I know of 3 filament manufacturers that can use this because they're similar size to Tangled, and I bet they don't. I'd be surprised even if they watched this podcast and found out about it, because this is an hour-long show. It's a lot to take in. But there you guys all go, and use it in your own projects. I have no doubt that this kind of mechanism, this passive drying mechanism, can be used in all kinds of other places. I'll bet it could be used in AC. Like saturate a bunch of microfiber cloths to create like a mini swamp cooler and that kind of thing, or a little personal AC, or all kinds of stuff. I don't know, but these sort of gravity-powered things I love. Oh, if you want a side project to just taste down, Google the Gravity Light. It is a failed project from an NGO, but it was a really, really good idea. And I have no idea if it ever went south or what happened to it now. It might still be manufactured, but it was a really good idea based on this type of a principle of using gravity for energy storage and generation. Okay, moving on to the next thing. Teleport and API. Okay, so a week ago, we released the version 2 of Teleport, which is now totally free. So you get 30 orders on the new baseline shipping system. And that will get you going so that people can actually get started completely for free without some little $10 secret fee after 90 days. We're very happy about that. The team's also been working through it, so there's been some teething over the last week or so, but for the most part, the transition has been really good. The biggest issue that we've seen is folks keeping multiple systems on, so like ShipStation and Shippo turned on at the same time, so an order gets double processed, or just transition stuff, not connecting your store to Shippo, that kind of thing. We're working on getting more content out about it, but the main thing was just focusing on the software and the product to make sure that it was all working well, and also making sure it had settled out. Because if we build up all this content, it's really tough to build it up again in case we have to make some major change because a user discovers something really, really blatantly off that we weren't aware of. But overall, it's going very well. Teleport Prototyper has been released inside of Teleport. That did not release with the version 2 initial release, but now there is Prototyper, and Prototyper is so much better than it used to be because Prototyper used to require a shipping integration in order to work with it. But this new version is kind of an independent app from Teleport inside of Teleport. So it functions completely independently. You can just sign up for Teleport, as in like log into it. You don't have to put in a credit card. You don't have to sign up for shipping. You can skip all that stuff. Just go straight to Prototyper, and you can upload files and mess with pricing and see what it all is. We think that's a really good, it's a big improvement over the previous Prototyper. So people will be able to play around with it a lot more and get a lay of the land before committing to something. Because the old Teleport, it was more cumbersome with the old version of Teleport, so now it's a lot easier. We are working on trying to continue to improve that a little bit more, but it'll come over time. Right at the moment, Teleport, but yeah, the transition went well and just in time. Right now, Teleport's processing somewhere between 100 and 1,000 pieces per day ever since the release of V2. So we're staying ahead of stuff. We're adding more machinery to keep it all rolling, and we're working to get more people in. One of the people that we want to add is a customer support or a client success person. And what we want to do with that is effectively anyone who signs up who looks promising, or we actually don't know how to do this because there's too many signups coming through to give everybody an onboarding call. But maybe like premium tier subscribers, or I don't know, somebody who asks for help or raises their hand and can ask for help, we'll do an onboarding with. That person would be committed to that so that people who are brand new to Teleport can get the lay of the land and also see all the cool stuff. We are also going to be building out the content of it more, of course, to show those previews. And now that Teleport is done, and quite frankly, this release is a big old bone rebuild of the system. And Everett, our lead developer, has been leading this whole thing for the beginning part of this year, and they've done a great job. So props to them. It's across the finish line, and it's really funny. I was just mentioning this today. After we got this launched and got through all the bugs and stuff, the system all now is really stable. So it's really easy to add stuff. And there was like a new feature, an internal tool that we built. And I literally said, like, was this built in the last day or two? And he's like, yeah. I was like, oh, it's so nice to have everything sort of done to where we're not working on the fundamental tech anymore. We get to start putting in all these cool little tools. And you will see that inside of Teleport. A lot of things will start breaking loose. I have no doubt that maybe even by the time this video releases, you might be seeing a new dashboard inside of Teleport with better analytics and that kind of thing for sellers, which we have been promising for a while. But again, we've been rebuilding the bones of it all. The GitHubs be bright green. But yeah, the Teleport, it's a really nice upgrade, and it's really nice to see. And it'll let us springboard from here. The other part of that is Teleport is running on our V3 API, version 3 API. The V3 API has not been publicly released because we've been using it internally to build Teleport and to build it out. Over the next few weeks, that API, we're going to revamp, we're going to release V3, release documentation on V3 and open it up to the developer ecosystem. So anybody who wants to build an app and put it on top of our print farm and have our print farm available to just print parts for you, if you're doing like an AI generated thing or a little kit bashing thing, the new V3 API will be pretty darn cool, and it will go from there. So all good stuff. I don't think there's anything else on that. Okay. Wow, this is going to be a long podcast, guys. We are half an hour through already, and there's more stuff to go through. Discussion topic, negative feedback. Oh, yeah. 3D printing professor released a video. Joe released a video about Teleport the other day, and it was not flattering. Like, it wasn't. We sent him a part that wasn't very good. That happens. It happens. I'm not interested in like arguing it or anything like that. His parts are what they received. And to go like engage in like YouTube drama or something just isn't productive. Here's the thing I will say. It's stupidly helpful to get those reviews. Right now, the main way we get feedback on Teleport Well, the most obvious way we get feedback. We have people doing support calls and those kind of things that we also throw into this number. But one of the biggest pieces of feedback we have is just the instant refund button. If somebody cancels an order after the order has been delivered, print quality was probably not good enough. That occurs, order cancellation occurs for any sort of reason or instant refund 1% of the time, 1.3% of the time. So it's not common. Because one of the references we use on this is like other fulfillment companies like UPS. UPS, when they quote a B2B kind of thing, they'll say 1% of packages might get lost. That's the margin that we operate with. They're generally not quite that high in our experience, but that is what they quote you. Like that's the expectation they set. So we are staying up with them and we're very happy about that. But bad parts will go out, especially if they're on the edge of what should be done. So when Joe did the video, we absolutely investigated it. We want to know why the part went bad. We want to see why it was. Joe did have a design note included in it where he said, we don't recommend this be printed. And yeah, the guy said it was FDM. Joe mentioned that it probably should just be said with our service. That's reasonably fair, but I can't train my team and everybody who works in production on the politics of 3D printing. So when they design a feedback note, they're not thinking about the ramifications of the statement that shouldn't be printed with FDM. But this is like one of the pieces. This is one of the little goblin fellas or something that we've been like reprinting. So this was a reprint of it after we redid it. And the one Joe got was worse. What happened was it ran through the system. It got flagged for manual reprint because it failed in printing. It got flagged for manual reprint. The parts were reprinted. The cost of it was like $3. And then it was shipped after the second reprint because it was manually sliced. There's nothing we can do about it. And this part, we don't recommend anything smaller than a cubic inch be printed through teleport. And this is smaller than a cubic centimeter. The reason we don't recommend parts this small is because while it may have worked for Joe, someone else who is less experienced can't really design this. And when our technicians are tracking stuff, they just track it for this. Normally, these types of parts would be flagged and rejected by the system at upload to where you can't order them, but Joe uploaded them in a batch. So it was a set of like 8 pieces that were all printed at once. And I can't show them all because Joe did not show all of them in his video, so I don't want to do any sort of IP release of them all. The other one was a tolerance on this tray here. And yes, it does come apart. I think this one, the tolerance fit of this, the biggest thing was Joe prints his parts at 0.1 resolution and the teleport resolution is 0.2. It's over there on the FAQ page. We're pretty transparent about that. But that 0.2 resolution creates more sloppiness. The other thing is printing it in gray. Gray is we have a really popular video on the channel where we talk about white, and gray and white are pretty much the same. There's a colorant called titanium dioxide in these materials, and titanium dioxide is a really chunky colorant which changes the flow properties of stuff. And gray is the worst one for high tolerance and high precision and it's tiny feature type of parts because its flow rate is a little bit different, and you can't really compensate for that flow rate reliably by just saying push out more, but it's kind of more restrictive. So you get different dynamics of it. Joe's parts all looked to be printed in like black. I don't want to say that. I think they were printed in black. Oh no, they were printed in like a blue, and blue has less of that light colorant inside of it, less of that titanium dioxide. So it's smooth. It prints more crisply, especially when it's small. Also, if these parts are not batched, you don't have all the retractions in between them and all the travel moves. There's also this other little fella like this who had some stringing on it on the one that they received. With that big tall sword right there, if you hit it with a heat gun, there's a danger of it warping the sword. So the guys are careful and they're like, we just gotta leave it. And like the parts aren't coming out well anyway. So when a part is not printing reliably, the point of sending the bad parts along is to be educational. It was a $3 set of parts for Joe there. So they think it's worth the education to send the design feedback back of like doing this kind of stuff. Because teleport is used by a lot of brand new 3D printing people who just don't know what is doable and what is reliable. Because they're not like deep in the hobby and that kind of stuff. They're trying to create a business. So we try to just give them feedback of like, this is something you probably don't want to run. And in the context of 3D printing, teeny tiny little thin parts like this, or thin parts like this, are not something you really want to run. Can they run? Sure. Do you want to run them? No. These are printed at a 0.2 resolution in light gray to where you have a lot of problems compounding. So yeah, there's our response. Oorah. But this leads into the discussion topic. What happens when things go wrong? Things go wrong all the time. From our perspective, this is awesome. Number one, it's great to have negative feedback because at least somebody is using it. The other thing is that negative feedback gives us contextual information that we can't always get from like that numerical response. So like cancel the order, auto refund. The auto refundder is awesome because like we are the only e-commerce service on the planet that allows anybody to instantly refund, no questions asked. Let me say that different. We don't know of anyone else who does that because it's a stupid business model to give people unlimited time to refund it. We have a Costco level return policy. Oh, you shipped it, you got a 5-star review, the customer got it, they were happy with it, everything else, it was $80, you refunded it? Okay. If you do that repeatedly, we're probably gonna flag your account and shut you down, but you're allowed to do it. But that is like the ultimate insurance policy in order to keep us honest and make sure that we're sending good parts. But statistically, we are sending good parts most of the time. In a statistical anomaly, Joe got his worst parts, but he's also working in the extreme of the type of parts to be produced by Teleport. We don't recommend miniatures for FDM. I never recommend miniatures for FDM. But people can print them, and if they come out fine, great. But if they don't, they probably shouldn't use Teleport. But again, going back to negative feedback, a lot of companies think that negative feedback is bad. And it is, to an extent. It's nice if everybody loved your product. But that is such a utopian type of dream that it will never happen. If you are starting a startup, there's no possible way that everyone will love your product. There's no possible way. And in fact, if you think everybody loves your product, you have one of the worst products on the planet because you have a product that is meh. If everybody loves your product, you have 5-star reviews on everything all the time, and there's no one who hates you. That doesn't occur. If you have an actual brand, an actual identity, an actual opinion about how a product should be made, there will be people who love you and people who hate you. For example, Apple. Apple is loved by the people who love Apple and hated by Linus Tech Tips for legitimate reasons on both sides. So that will always occur. So you can hope for good reviews all the time, but you will not get them. Negative reviews are far more likely because negative reviews are what people do. People will far more often give a negative review, a 1-star review, than they will a 5-star review. Like it takes a lot of marketing effort to get people to give you a 5-star review because they're like, it was good. I don't need to give you a 5-star review. So you take the negatives, and the negatives are really good data to figure out, oh, this is what we need to improve. If there's multiple negative reviews about a certain issue, fix that issue. We are in the advantageous position of being a software-based manufacturing technology to where we can evolve and improve over time. We are also just a company that likes to evolve and improve. Let me pull down an example of this. This was not in Joe's review, but it was something that irked me when I was watching it. Because the guys, when the video passed my desk or something like that, I got a message about it, like, hey, we should watch this video. And I pulled it up, and the first thing I saw, I was like, oh no, it's an unboxing video. And when I said that in my head, I was like, unboxing video. There's the box. I don't like this box. I really don't like this box. This box is very affordable and very functional and very reliable for getting stuff out. It's also sized to be basically the build volume of our machines. So anything that someone prints will fit inside this box until they do multiple parts and then it's out the window. But this is the minimum size box to fit the build volume and also not increase shipping cost. So we can buy this box only in bulk and everything will go inside of there from little pieces to big pieces. But here's the thing. People who use Teleport are sending it to final customers. We're not sending parts to engineers for prototyping inside of Teleport. It's a print-on-demand app. So you want an unboxing experience. This is not the replacement box, but it is a box that we are trying and ideas that we're playing around with of how do we take a very boring brown experience and upgrade this. This is one of the experiments that we're doing. We're playing around with how do we make the box discernible, identifiable, not necessarily branded, as in like put a big old Teleport T across the top, but just distinctive and interesting and a good experience to open up. We're messing with the interior filling, messing with the colors of the labels. All of this right now, the only thing stopping us from like deploying some version of this is just how expensive it is. This white box is 2 to 3 times the expense of this brown box. And you also might have noticed it's smaller, which means it doesn't work as often. This blue sticker is 2 to 3 times as expensive as this white sticker, and so on. So we want to keep Teleport affordable, but we also don't want a nasty beat up brown box sitting on people's thing when they pull out a beautiful vase or a beautiful lamp. Because a lot of people who use Teleport are designers who want to get their product out in the world. So we're working on that. That is an improvement that we can do. And negative feedback helps us to improve that. Literally having Joe's video go live to where I could see that beat up box on top of his desk, that is useful just to make sure that we get our tail in gear about that. As far as the print quality and that kind of stuff, absolutely, that's always a thing. But we have active feedback on that from both refund, parts going through. One of the things we want to improve inside of production is better photo attribution of parts. So every batch of parts that goes out the door has a photograph taken of it before it goes out. So we have better tracking on that. As to why the parts that went bad went to Joe, it's kind of a human factors thing. And I don't want to go into that because anything that goes out the door that's bad is on my fault. So there was a failure in the system to where we need to adjust training or adjust system checks and that kind of stuff. But again, also, we're not going to change our policy about parts this small not really being recommended for Teleport. Because they're not. There's too easy for things to go wrong on this. People will design these tiny little pieces and they won't be reliable. Because if you can't make 1,000 of those and have each one of them be a good print, then it's not really ready for production. And that's kind of the standard that we attribute to Teleport. So yeah, there's all that stuff. But negative feedback is not something to be avoided. It is something to be encouraged and sought after because that's how you improve. You don't improve from, hoorah, we did a great job again. Pat on the back. It's like, great, what did we screw up? Eliminate that. How do we get less wrong each day? And if a company can do that, if you are trying to be less wrong, then you are trying to improve the product for your customers. And Warren Buffett says no company has ever gone out of business trying to do a better job for their customers with actual truth and intention. There is no reason for us to send bad parts on the regular because if we send bad parts on the regular, we go out of business. So why would we want to do that and hide it? Because every user who gets a bad part probably isn't going to use us anymore. So there is no way to grow and sell more if our users are all getting bad parts. So we have to work to do it well on most of them. And right now we're doing it well on 99% of them. Is that good enough? No, because there's still that 1% that we got to chase down. Beyond that, though, the negative feedback helps us find those edge cases where we need to chase it down. This is great because in Joe's case, this was a great lead-in for the need to create a different settings category. Because Joe was printing his miniatures, I believe he said in 1.15 or 0.1, basically bamboo settings, that kind of stuff. And ours print at 0.2 because we do a lot of functional parts and then we do some of the smaller parts. But generally, at any part, the ideal 3D printing part is about the size of your fist. That's ideal cost, production value, quality of product. At that level, a human really cannot notice the difference between 0.2, and by human I mean consumer, not 3D printing nerd. We know this from the thousands of parts we've sold in other places and with our production clients and partners. So there is a need though for Teleport to have categorized print settings. So like here are print settings for uber small parts. Here are print settings for functional parts. Here are print settings for lamps. Teleport has no print settings options in it right now. Hence why we got version 2 Teleport out the door. And I think you guys will be very delighted with the stuff coming down the pipe. But each time we introduce a new thing, you have to realize that each time we add another thing, we introduce infinite new complexity. Because anyone can upload anything. There are 200 settings that can be modified in the slicer, and we have 9 to 12 materials right now. As soon as we add in another set of print settings, we just multiplied by anything anybody. One new setting can be applied to the infinite anything that could be uploaded. All the materials, 9 times 9 to 12, times the settings variations. So you're dealing with a very complex expansion to where the difference between printing a tall, thin, vertical PETG piece and a fat PETG piece is night and day. PETG is really temperature sensitive. If you have a default profile for PETG, on a fat part, a layer may take so long to complete that it cools so much over here that your layer adhesion goes out the door. But if you, because the whole thing cools down in the time span that the nozzle gets back around to the start. But if you do a really tall and narrow piece, and you've increased the temp to deal with a fat piece, the tall and narrow piece will have too much heat concentration without enough cooling because it gets back to the start too quickly. And then you can have an ice cream cone. Or you make sure you have a crisp, small part, and then you have bad layer adhesion on a fat part. Those are the types of problems that we're dealing with, which means that, and we cannot rely on the user to solve those problems. So in like the fat and thin part, we need to do an analysis on the part and say, okay, the cross-sectional area, maximum cross-sectional area is this, therefore we can use this print profile on it reliably and that will get the best part. And then for the narrow part, well, it has a cross-sectional area of this, so we need to use this print profile. That can all be done, it's just more stuff to do. And as we add in new settings and new variations, all that stuff multiplies. So you have to keep it as simple as possible. So right now, Teleport has 0.2 resolution, 25% infill. And we don't recommend it for uber small parts, below 1 cubic inch. But we are evolving and improving as fast as we can. And we really appreciate the fact that Joe took the time to make that video and share that feedback with us, because it is really helpful to get an analysis of it all from somebody else who's outside of it all. I reached out to him, I sent him an email and said, hey, would you want to do a secret shopper with us once a month? And this can be the open invitation to it too, if Joe sees this. If you want to do a collab / well, it can't be a sponsorship because we'd be, hey, do a secret shopper with us, we'll pay you. But it would be cool to have someone in the community who like once a month creates a fake email account, a fake Teleport user account, and buys a part from us that's literally a torture test. Gets that part shipped to them and sees how it did and what we did and how'd it go and how long it took, and gives a video review of it for the community to see. That would be really sick. If Joe is willing to do it, we'd like to do it. If Joe doesn't want to do it, somebody else reach out to us and let us know if you'd be willing to do it. After you do it, after you post the video, you can reach out to us and we would, I don't know, refund the order. But yeah, with Joe's video, it was kind of a big kerfuffle for a $3 order, but it's still useful. And yeah, so I go watch the video. I recommend it. We're working to get better. He got a bad set of parts, but we're continuing getting better. And but I guess I have the excuse of like we shipped 1,000 parts, so it's like we're doing well. But yeah, happy to go down. Oh, by the way, to continue the trend, down in the comments, let us know what's wrong with Teleport, and we'll try to get it fixed. Go crazy. Bring it on. I can take it. I can take it. Keep it coming. I got my Dr. Pepper. I'm happy. Hit me where your breast shot. Okay. Okay. That's discussion topic. Good times. But sincerely, if anybody has problems with teleport, comment down below. Okay. Wow. Yep, here we are. Long podcast. Questions. Going on to questions. If you would like to have a question that I need to answer on the show, go ahead and comment question : what your question is in any of our videos, and we will search it up inside of our stuff here and then answer those questions on the air. Oh, side note, we might try to start taking podcasts back to live streaming since we got this whole new set and stuff. We can hopefully have a better internet connectivity than when we tried doing live streaming last year. So we may bring live streaming back and do the podcast live again. Question: when will tutorial videos be coming out for new teleport? That is a good question. As soon as possible. We're working on them. We wanted to make sure that V2 was actually out and live, and we kind of wanted to slow new user signups because when we released V2, we also opened up signups so that a few people could get into it and more people could do testing and betas and stuff. But we didn't want to help anybody accelerate new users. So we haven't done the tutorials. The new Slant Pod site is up, which has some resources over there. Most of the new tutorials will be written because it's just a more scalable way of doing it than videos. There will be screen shares and screen caps and that kind of stuff. But yeah, new tutorials will be coming out on Teleport over the next few weeks and so you'll see those on the slantpod.com. Question: what's happening to Tangled testing? Tangled testing is still active, still there, still on the docket. We just need time to get back to it, and also format. So Tangled testing, I think we got the baseline 15, 20 videos out over there, and we'll continue doing more now that Tangled is getting into a point of stability. It's just a question of like focus of projects. Like, we do a lot of stuff at Slant 3D, and we need to make sure that the core stuff is being done well. And Tangled testing is a good thing to do that we will have to continue to do and will continue to do for the next 5 to 10 years. But it wasn't something we could do in these 4 to 5 months. But actually, content over there will probably start ramping back up because the content team is expanding. We literally just hired another person just the other day who's joining up the content team. So hopefully the Slant POD YouTube channel, Tangled testing, those kind of things, we'll get to have a little bit more content thrown out there to them. And core channel will have more content to it. So hopefully that will come through in the content. The beginning of this year, we've been revamping stuff and building a new set and things. Okay. Question: I often hear leave a gap of 0.2 or 0.5 millimeters between the object and its support, but do I have to put something between the support surface and the object? I mean, there's still air. No. If you're welcome to the 3D printing. Support is literally meant to be spaced off from your part. So if your part is right there, and this is the top of your support over here, my knuckle, you do want a little bit of gap right there so that the top of the part falls onto the support, 0.2 millimeters. And that way that support will break away when you finish making the part. So yeah, you just have air inside of there. Right now there's a bunch of videos going around about putting stuff in between. Shaving cream, a Sharpie, whatever else it was. I don't know, I haven't watched the videos because I don't agree with that philosophy, but that's because I'm a mass production guy. We don't have time to go through and paint every one of the supports in between stuff. That's something for the hobbyists who want to polish a thing. Will you be responding to 3D Printing Professor video? Done. Yeah, we did. Like, the negative feedback is great. I'm glad Joe did that video. I have no ill will. And if he wants to do some collab videos in the future where he does secret chopper on us to give feedback, do that. Okay, cool concept, but the print quality, what? Print quality? Oh, mostly added fuzzy skin. The fuzzy skin. But the print quality discussion between does fuzzy skin look good or do virgin layer lines look good? I like fuzzy skin. A lot of consumer products like fuzzy skin because I see them go by. Oh, guys. There was a part that went by the other day through Teleport that literally everyone in the company looked at. It was so beautiful. Oh, we asked the person if we could show it, because we cannot show parts from Teleport because consumer privacy. We do not share files. We do not show off anything. We cannot film around those machines. But there was this beautiful part. It was so perfectly textured, so wonderfully designed, so lovingly thought through, and it came out so perfectly because there was no way that it could possibly fail. Everybody looked at that, and it was such a beautiful part. I hope that the designer, it was a prototype part. They were trying out Teleport. I hope the designer will let us share it on the air because I really want to share this with you. But they were using texturing with it. It's beautiful. It's so beautiful. The texturing, when done correctly, is just beautiful. If you want to see some good uses of texturing, also go over and check out Make Anything. Devins does awesome stuff with texturing. Question: the $3 plate fee has become a perverse incentive for batching. Can you advertise that cost instead? Oh, okay. This was in relation to perverse incentives question a couple weeks ago. The $3 plate fee, yes. Basically the picking fee for an order. People want to shove a bunch of stuff on a plate to try to save the $1 to $3 for the plate fee. It's not a perverse incentive. It's a poorly directed incentive, and an analysis problem inside the system. Literally, the way we fix batching is we just need to update the pricing algorithm to identify individual bodies inside the STL being uploaded so that batches of parts price higher. And right now, we don't do a multi-body analysis on a print, and that will be coming into Teleport. So anybody who is batching currently, you will see your prices go up in the near-ish future because batching. You know what the fundamental problem with batching is if you have a plate of 5 to 8 parts, and like Joe had this problem too. If you have 5 or 10 parts there sitting on the build plate and one of them goes wrong or one of them is unprintable, in order for us to do a good job, we have to either manually reslice for that one single individual part, or a person has to go in and cut out one individual part and create a profile for that to try to fix this so the person gets a good part. Batching is so incredibly labor intensive in order to fix a problem. Or it's machine and material intensive to just reprint the whole thing again. So batching is a very bad practice because number one, everybody does it wrong. And it's just, it creates more problems than it solves. So with that regard, yeah, we're just going to create an incentive structure to where if you are uploading multiple parts inside of a single file, each one of those parts will basically be counted to where it might not be, it may be, I don't know where to land. We got to mess around with it. I don't know where the pricing algorithm will land on that. But batches of parts will get more expensive because it's just expensive to deal with. Question: any video tutorial on new shipping integration? Oh yeah, video tutorials for Teleport coming out soon. But literally the walkthrough when you sign into Teleport leads you straight through it. It's not hard. It's not hard. It takes literally about 2 minutes, 30 seconds to 2 minutes to set up new Teleport. It's very, very seamless. Question: would you be open to working towards a system you discussed about a designer uploading a model? Then individual sellers access the print and sell the models without access to the STL or design of the model. This sounds like an awesome system if you implement it. Yes. Talked about this to where we basically hold 3D designs inside of Teleport, and then the sellers can access prints of those designs, but never actually have access to the file. Because we're printing all the models, we're just like, oh, you can sell these prints in your store, so you can match to that file, but you don't actually get to download the STL. So the designer is protected and can pull back control of the STL or anything else. That is absolutely on roadmap. I don't know when it will be released. We technically did release it once already. It was part of the Etsy integration last year. We did not push it very heavily because we were busy with other stuff. And the Etsy got kerfuffled kind of middle of last year or late last year. So we didn't have a lot of time to work on it, but we know how it's done. And when building a product, you generally need about 2 to 3 tries to get it built. Generally 3 tries to get it built in order to do it right. So we got 1 rep under our belt that last time. I'm pretty sure if we did it again here, it would be really cool. It's a bigger project than it sounds like because we need to track royalties for the designers. We need a designer portal, designer interface. We then need to build that teleport-facing catalog for people on the other side. It's challenging. So I have no idea when we would release that or when we get to it, or even if we'll get to it this year or next year or whenever it is. But we definitely want to pursue it because it's a good thing for designers. It protects designers just extremely. And like we've discussed this with designers, but in order for us to do that, we would need somewhere between 5 and 10 fairly large designers on board with it to kind of be evangelists. So if you are currently a designer who's interested in this and wants to do it with Teleport, shoot us an email and we can discuss it with you. Because we also want to make sure that it's designed for the designers and not necessarily something that we just go do. Okay, next question. Have you considered allowing people to submit OpenSCAD code instead of an STL? It would also be for people to have dynamic models like the customizable ones on MakerWorld. You can export an STL from OpenSCAD. We can't do OpenSCAD code directly. You would have to build an OpenSCAD script or system that would just generate the STL and shove it into Teleport. Teleport is not built for like software integrations. It is a customer-facing platform. However, if you want to build an application that uses OpenSCAD to generate a 3D model and then just generate the STL straight from the OpenSCAD export, which is super easy. An STL exports from STL or OpenSCAD very simply. Then you can have that output really readily and build a really cool app on it. Okay. Next question, Delta Factory. I was going to ask about stacking parts for mass production as I considered using the API or Teleport for my store. I have a tool bin divider that is essentially a flat piece of plastic of a certain size. I can only get 3 to fit on a 220 by 220 bed, but sell 8 packs. Printing vertically would weaken the part, so I would have thought stacking was an efficient solution instead of using multiple machines for one order. How do you recommend layering out the bed to maximize print farm while minimizing cost for a very simple part? I do not recommend stacking because going back to like the batching problem, stacking is batching and on steroids with way more problems because when you're stacking, you have way more opportunities for failure because you have a fundamentally unstable system to where everything has to fall just right or else you have a failed or low quality part. So the kind of the fundamental rule that I follow is that your product in e-commerce, the average order size is somewhere between $25 to $50. Anything from a Ridge wallet to a frickin' set of cookie cutters. That is the pricing that you want to hit if you're selling a product in e-commerce because that pays for shipping, that pays for marketing, it pays for everything else. That seems to be the sweet spot. It's also the price that most consumers are ready to pay on an impulse. If your product is cheaper than that, you need to pull together multiple pieces so that it gets up to that price. And knowing that, we have tried to structure Teleport to support that level of pricing. If your item needs to be sold for less than that, like you got to make these 8 pieces for $10. Teleport might not be the right option because it's just you're trying to get more efficiency out of a system that's just not feasible for a print-on-demand component at this time. And if you start trying to hack it in there, and it's causing problems for us, you're in an unstable position to where we're going to restructure the system to try to charge you more because you're causing a lot of problems for us. That's going to create an incentive structure. So I don't recommend stacking. Stacking is a really dangerous way of trying to get more parts into a build volume. If you designed them to where like they were all legitimately one part, not stacked on each other, not like this bottom part is support for this top part is support for this top part, but literally had them fused together and made them like breakaway or something. I have no idea how this would work, but if you can think of a clever solution to where it is a single part that prints reliably, then maybe there'd be a way to get it done, but then post-processing goes weird and everything else. Let's see here. Question. That's not a question. Question. Can you do a future POD segment on Zellerfeld? C Kitchen just made a very interesting video of their factory. They're an oddly similar company to Slant 3D, just specifically printing shoes. Zellerfeld is a really interesting company. Cornelius, the founder and CEO of Zellerfeld, worked with us back in like 2018, 2019, kind of when we were getting started up. We printed several prototype shoes for him, but they're doing something so specific that they needed to generate the machines themselves, and they did. So Zellerfeld is great because Zellerfeld has this really great focus on shoes, just making shoes. And in that video with CNC Kitchen, Cornelius made a really interesting point, a really prescient point, that he's like, the shoe industry is large enough that it is worth building a custom slicer for just slicing shoes. And I was like, that is a perfect explanation of how to pursue a niche. This is really big. We don't need the whole world of how to make plastic parts. We're going to focus on this one area and be really good at it. And Zellerfeld has been very good at operating within the niche of making shoes, to where Nike used them to make some shoes. That's great. Zellerfeld has been funded by Founders Fund and everything else. Like I have tremendous respect for what Zellerfeld has done. The difference between us, Zellerfeld is a print service for making shoes, but they're also a shoe brand in a way, whereas we are more man behind the curtain, to where we're basically a white label service. Somebody can produce a part on us. We have the giant problem of trying to make any part. We get around that by just limiting the amount of variables that occur in it. Like going back to 0.2 resolution, 25% infill. We can make the vast majority of parts under those conditions, and we can also control, direct, and give feedback around those conditions. If we open up the print farm to make anything, and we say we can make anything, then you get into a really dangerous situation to where you have no idea how to optimize. Zellerfeld just makes shoes, so they can optimize everything about how do we make good shoes. What is the material? What are the profiles? What is the software? What is the machinery? How do we make shoes? We've done that by going from how do we make a reliable 0.2 resolution PLA PETG part, and just starting right there, being really stable right there, and then you can expand from that. So Zellerfeld could start with shoes and expand to sports equipment of some sort. Make a squishy helmet, something like that. We can expand from PLA to carbon fiber, something like that. So there's different directions of going at it, to where we just restrict the number of variables by just restricting the number of variables, and they restrict the number of variables by focusing on that particular niche. Who will win? No idea. We have a pretty good edge on it all. We're doing well. They have a pretty good edge on it all. They're doing well. I don't know who's doing better. I honestly don't. I need to talk to Cornelius. I invited him on the podcast. He didn't get back to me. We couldn't get something scheduled. But I'd like to talk to him on podcast. Vote below and hit up Cornelius on Instagram, Zellerfella, and say, hey, you should get on the Slant 3D podcast. Question, in what EU country are you going to pop up the new factory? Would like to apply but cannot move at this point in life. Also, how far is the future of the EU factory? Weeks, months, years. Oh yeah, the EU factory is going to be built just months from now. Probably we're going to go ahead and stick it in. And yeah, that should lay it all out. But yeah, we'll get that rolling here soon. Okay, that is questions, guys. Hot dog, that's a long show. Good luck to the editor. I did not drink all my Dr. Pepper. That's good. I can save it for later. I'm going to go to bed, just like put a nipple on that. And Be a grown child. If anybody has any additional questions, go ahead and comment question : whatever your question is down below, and we will answer them in a future show once enough of them pile up. Looks like about every 2 weeks is when we're running questions right at the moment, because that's a good number of them accumulated. Beyond that, let us know if there's anything or particular topics that you want us to talk about in podcast, and we will go from there. Have a great day, everybody.